Hello everybody. Today we're going to have a look at transformations of functions, and specifically we're going to look at reflections. We've previously looked at dilations, and in the future we will look at translations and combos. So yes, it's a fascinating subject, even though you might not like it, but come on, we're going to have some fun together. What is a reflection? Well, it's if a point x, y, it is said to be reflected in or about, that's the correct terminology, in or about either the x or y axis if it is transformed such that it becomes the exact mirror image about the axis that it is reflected in or about. Does that make sense? I hope so. It'll become clear in a moment. E.g. the point 3, 2 is reflected about the y-axis and about the x-axis. What is the image of this point? Alright, let's do that. Here's the point 3, 2. Now, we're going to reflect it about the y-axis. So you think about where it's going to go, can you? This is where it's going to go. There. Don't you know? That's where it's going to go now. The thing for you to notice is that the mirror was the y-axis and the x value was what got affected. You see that? So therefore the image is -3 and 2. For B, we're reflecting about the x-axis. So you think about where that's going to go now, about the x-axis. There it is. And the mirror is the x-axis and the y value was affected. So the image in this case is 3 and -2. Okay? Get it? It's fascinating, isn't it? Here comes some calculations. Now I'm going to do forwards and backwards with the recommended or my recommended logical method, and then forwards and backwards with the quick cookbook technique. Okay, so here we go. Forwards, in which you are given the original function and the transformations required to do to it, and then you are required to come up with the end result, the transformed function. E.g., if f of x equals root x, determine an equation for the image of f of x after a reflection about the x-axis, and b, a reflection about the y-axis, right? This is A. Now, okay, think about this. We're drawing a diagram because diagrams just make everything clear. We're reflecting about the x-axis. Let's do that. There it is. So the y gets affected, right? So xy becomes x and minus y, and I then call that the final transformed point, x dashed y dashed. Now, from that I get together two equations which I call the key to everything. And this is the first equation that we started off with. I say y equals f of x, which is root x, and I call that equation star because it is the star of the show, along with the key to everything, which I'm going to produce now. That's the key to everything. Now I'm saying that x dashed is equal to x and y dashed is equal to minus y, because that is the same as that, right? And then what I'm going to do now is I'm going to make x and y the subject of those, like that, and then I'm going to plug those values of x and y, this x and this x and this y, into the equation in terms of these transformed beasties. Then we'll come up with our transformed function. So we substitute for x and y into star, and we get that. Minus y dash, because minus y dash is the same as y, equals f of x dash, because x dash is the same as x, equals root of x dash, because x dash is the same as x. Now we solve for y. That's what you always do. You don't leave it like that with a minus in there. You solve it for y. And there it is. So therefore, that's basically our transformed function, okay? And you now drop the dashes because the final transformation has occurred, and the new function stands in its own right. We no longer link it to the old one, and therefore the image is minus f of x equals minus root x, or if you like, you could probably say y equals minus root x, depending on what they ask you in the question. But that shows you what's happened to f of x and in the original sense, and what happened to the root x in the original sense. They both got minused. Look at the graph opposite for my final little animation to show you. We started off there and we finished there. right? We reflected about the x-axis. Now let's do the y-axis now. Let's draw the diagram. We're reflecting in the y-axis, so where does it go? Don't you know? Come on, off we go. There it is. Okay, so we reflect in the y-axis and the x gets affected. Yes, the opposite one gets affected compared to what the label of the axis is that we're reflecting about, or in. So xy goes to minus xy, and that's our final transformed point, x dash y dash, and now we do the calculations here. We say so. We started off with y equals f of x equals root x, equation star, and now we come up with the key to everything. So y dashed equals y. Okay, what am I saying? I'm saying y dash is the same as y. I'm saying x dash is the same as minus x. Then I make x and y the subject of that. That's the key to everything. It is absolutely is the key to everything. Those little bits there. There. Now, we substitute for x and y back into our equation, and what do we get? Equation star. We get y dashed, which is the same as y, equals f of minus x dash, because that's the same as x, equals root of minus x dash, because that's the same as x. Now, that's already solved for y, so that's really our finished answer, and you could either answer that after you drop the dashes. You could probably say y equals root of minus x, or f of minus x equals root of minus x. Both answers would most likely be acceptable depending on the wording of the question. Here comes the graph, eyes left. That's what we started with, that's what we finished with, and it's beautiful. Are you happy? Do you get what we're doing? Good. Now we're going to go backwards now. This is with my recommended technique. Backwards is where you're given the beginning function and the final function. You have to come up with the transformation steps which have been applied to get to that final function. Yes, now, okay, so determine the one reflection which has occurred when y equals 1 over x minus 4 is transformed to, firstly, y equals 1 over minus x minus 4, and y equals minus 1 over x minus 4. Okay, alright, that's good. Now, the way I do this is I put them in equivalent, what I call equivalent form, but I'll just show you. That's the original equation. That is the transformed equation with dashes put as little superscripts for the y and the x, so that's y dash and x dash now. Alright, now, by the way, I want you to be extremely careful, this is a little segue, about how you write that minus there. See that that's written like that. That means that that minus is inside the span of this vinculum, this dividing line between numerator and denominator. That says minus x minus 4. If that dash happens to stray out of there and be outside, then you're minusing the entire fraction, which would become basically minus 1 over x minus 4, which is a entirely different proposition to this thing here, where the minus sign is within the span of the vinculum. So a lot of students get very careless where they do these minuses at the start of some term with a numerator and denominator, and they actually say something different, maybe in an answer, and get it wrong. So you just please be very careful with what you're doing. Don't get careless, because you can actually say something else that you don't mean if you get careless with minus signs when you've got these denominator things happening. So that's the end of my little segue. Now, those expressions are in equivalent form because the interloper, the different term there, the minus, he basically belongs to this x term. So that all extra terms that you put in the transformed function have got to belong to either the x or the y, and he is firmly belonging to the x term, so that's alright, they're in equivalent form. So now we can equate equivalent terms, and we can say therefore y dashed equals y. Yeah, we're saying this beast is the same as this beast, yeah, and we're saying that this x minus x dashed minus 4 is equivalent to x minus 4. Now that's the key to everything. We're going to solve for y and for x now. That's what we're going to do. Yes, that's good, very convenient, and therefore that's the case, and therefore oh, we're going backwards, aren't we? Oh, that's right. When we go back, sorry about that. When we go backwards, we don't make x and y the subject. We just leave it as y dashed and x dashed are the subject, because that's the transformed term. So we're reading off the transformations. You make x dashed and y dashed the subject when you go back in the backwards technique, right? So I'm saying y dashed is the same as y, so there's no transformation been applied there, and x dashed is the same as minus x, so therefore you had to reflect x in or about the y axis. Yes, that's what you had to do. Alright? Excellent. Here comes part B. Now this one here, that's the first untransformed function. That's the transformed function. Now this is a bit of a problem here. This minus 1, that minus, he's the interloper here. He's the different thing about this transformed function. Everything else is the same. He's either got to belong to the x term or he's got to belong to the y term. At the moment, he's just swanning around here trying to look inconspicuous, but he has to find an x dad or an x or a y dad, if you like. You know, he has to belong to the x term or the y term, and he doesn't belong at the moment, so we have to fix it so that he does. So for equivalent form, equation 2 needs to be in exactly the same form as equation 1. The minus sign, that, is an extra term which needs to belong to the x dashed or the y dashed term, as I was just explaining to you verbally. So we look at that again. And there are actually two approaches that you can use for that. Now, you can make that minus 1 belong to the x term, or you can make it belong to the y term, depending on how you want to do it. They're both equally correct. But I think the actual question asked is for what one reflection would be required to turn this into that. So that might vary between the techniques that we use, depending on which x or y we make this minus 1 belong to. Now approach 1, I've made the minus 1 belong to the x term. So what I'm going to do, in order to achieve that, there's a little bit of smoke and mirrors here. I'm going to multiply the top and the bottom of this fraction by minus 1, which doesn't change the fraction. If you multiply top and bottom by minus 1, that becomes 1. That becomes minus x dash plus 4, and the fraction is the same. See that? But at least I've achieved a minus 1 up here, which is the same as it is up there. And really now what I've done is I've affected this x term. See? It's now minus, it's gone from x to minus x dashed, right? So that's what I wanted. Okay, now the minus 1 isn't swanning around not belonging to an x or a y. It's basically reappeared in this form here. Right, that's good. Now we can now they are in equivalent form. Equation 1 and equation 2a are in equivalent form. So basically equating equivalent terms proceeding with that, we can say that y dashed equals y, and we've got that expression there, minus x dash plus 4 equals x minus 4. Solve that for x dashed, and what we get, I'll do there, I multiplied both sides by minus 1, didn't I? Now, just cleaning that up a bit now. That's telling me, guys, I can read that straight off. To get from x to x dashed, which is what I'm supposed to do, read off the transformations in the backwards technique, I've got to multiply the x by minus 1, which means reflecting about the y-axis, and then I'm going to have to add 8, which means I'm going to have to translate in the x direction, positive x direction, by 8 units, or 8 units to the right. Now, that's basically what you have to do, but that's approach 1, right? Now that's more than just one reflection, which is what we were asked for. So I'll do another approach 2, and hopefully that'll work out just as one reflection, and that better be our answer if we're answering it correctly according to the conditions of the question. Now, approach 2, make the minus 1 belong to the y now. So what we're going to do there is we're going to go up here, and we're going to multiply both sides of this equation by minus 1. And that's, yes, I've just done that. I've multiplied both sides of equation 2 by minus 1, and I've called it 2b. So now the minus sign has appeared, the minus 1 has appeared as affecting the y term. The y term, right? And I've got a 1 here, which is the same form as what I had in the original equation. So now we're cooking along nicely, and they're in equivalent form. So I can say that therefore, equating equivalent terms, I'm saying minus y dashed equals y, and x dash minus 4 equals x minus 4, and I'm going to solve that second equation there. I'm going to solve them both. Make the subject x dash and y dashed. That's the y dashed, that's the x dashed. Now that's looking very nice because I can see a reflection there, just a single reflection. No transformation is happening here. That single reflection is about the x-axis. So therefore the y term is affected, therefore this represents a reflection in and about the x-axis. Now, here comes my NB. Both of these approaches to equivalent form are perfectly valid and correct. And both versions of the transformations occurring are correct and will give an equivalent correct end result, that is y is minus 1 over x minus 4. Because we were asked for one reflection in the question, we will give the answer according to approach 2, right? Now, there was some good stuff there. I hope you got something out of that. Okay, let's do the learned quick technique now, both forwards and backwards. In this technique, I've got to put the caveat there that it's based on the foregoing logical method, but it's not my preferred technique. But it is included for the sake of completeness because it's fast, sleek, pretty wonderful to use if you know what you're doing, but there are dangers associated with it. Forwards, you are given the original function and the transformation is required, and you're asked for the finished product, the transformed function. Here's an e.g., what we did before. F of x was root x. Determine an equation for the image of f of x after, firstly, a reflection in the x-axis and then a reflection in the y-axis. And what are the learned rules for the quick cookbook DRT or Dr. T technique? Because it is Dr. T when you, not when you're going forwards so much, but when you're going backwards, you have to quote them as in that order of DRT. For a reflection about the x-axis, replace y with minus y, and for a reflection about the y-axis, you replace x with minus x. It's always the opposite with this learned quick technique. Now, question A. What are we doing? We're reflecting about the x-axis, so therefore there's our original statement, y equals f of x equals root x, and to reflect about the x-axis, you replace y with minus y, so you get that. Now, you always solve for y, so therefore you say y equals minus f of x equals minus root x, okay? And that's our answer. The image is minus f of x equals minus root x, or if you like, y equals minus root x. Both should suffice. I just basically do it as a three-way little expose here, just to give you the flexibility as how you want to express your final answer. Usually y equals minus root x, or minus f of x equals minus root x. Usually both will do. It depends on how they've worded the actual question in the first place. All right. Here's B for you and me. We're reflecting about the y-axis now, so that means we're going to replace x with minus x. There it comes, so therefore we say y is minus, no it's not, it's f of minus x, which is root of minus x, and that's our image there. It's quick, isn't it? Sleek, beautiful. Yes, I know, it's beautiful. But it does have dangers, as I did explain in the previous video on dilations. Yes, it does have dangers. With the backwards way of doing it, actually. That's the backwards bit is the problem with the Dr. T technique, DRT. Now, stop rabbiting on, Wolfman. Backwards, here we go. Given the original and the transformed function, we are given that and we're required to come up with the transformation steps which have been applied. E.g., determine the one reflection which has occurred when y equals 1 over x minus 4 is transformed into 1 over minus x minus 4. And again, you'll notice that minus there is under the span of the vinculum, so it's basically the minus is only applying to the x term. If that minus had been stuck outside there, it would be minusing the whole expression, which is a different kettle of fish altogether. So be careful, please. Secondly, is transformed by number B, minus 1 over x minus 4. Alright, here we go. Now, learned rules again, restating them. Now, so with part A, we have the original and the transformed functions, and we can notice straight away that really the only thing that's been changed is the x term, and it's been changed to minus x, and I've called it x dashed, of course, to make sure I understand it's the transformed function, but it's quite clear to me that there's a reflection. The x has been made into minus x, so there's a reflection about the y-axis. Yes, that's what it is. Okay, number B for you and me. Well, the problem here is that this little, again, this minus here doesn't belong to an x or a y term. That you have to make it belong. It's got to be, if there's a 1 there, you have to have a 1 here, not a minus 1. So what we're going to do, the easiest way to do fix this is to multiply both sides of this transformed equation by minus 1, and what you'll get is that. Now the minus 1 has clearly manifested itself as belonging to the y dash term, and you've got a 1 over there, which is what I wanted. Now they're in equivalent form. And you can see, in this case, that the one that got changed, the only changed term is y into minus y dash, so therefore that's a reflection about the x-axis. There it goes. And that's the end of the story. Unky dory, eh? So I hope you got something out of that. That's how you do reflections. So thank you. Have another look at it. If you're not quite sure, have another look as many times as you like and you will get it. Think about it, and you'll get this stuff. Don't think about it, anything could happen, I'm telling you. So come on, invest some thought in it, and you will conquer. So we'll see you in the next exciting video, and have a wonderful day.